So in this class, we will discuss the concept of compound bars. So till this we have covered only one material, and that material is subjected to tension or compression. What are the values of corresponding values of stresses and strains that are going to develop in that material? Maybe a prismatic bar, or a tapering bar, or a stepped bar. In this class, we will discuss about compound bars. A compound bar or a section is the one which has got more than one material. So sometimes we have to discuss with compound sections. I have an example here. RCC column. As a civil engineer, this is the most important one. RCC column. So as you know, in RCC column there are two materials. One is concrete and another is reinforcement steel. So this is the cross section. So the column is a vertical member which can transmit compressive force to the foundation. So this is the foundation. And if you take the section of this column, it can be rectangular or circular or square, anything. So this here in this example I have taken a rectangular column section, and in this, if you see the section here, reinforcement is provided like this. You can see in section reinforcement as circular rods, circular sections. So that I have taken it as AST. AST stands for area of steel, and remaining thing will be concrete. So both together is RCC. So the main thing is why these two materials are used in RCC, because concrete is very strong in compression, whereas steel is very strong in tension. So normally in any building, all the types of forces will be acting. So building will be subjected to bending moment, shear force, deflection, stresses, all those things. So if you adopt the combination of concrete and steel, definitely both tension and compression forces will be taken care. So here, to analyze such problems, normally they will ask you to find the stresses in the two materials. So they will give the load, whatever force is acting on that particular column, and they will give the areas. So total concrete area they will give, and how many reinforcement steel bars are given, that they will give. So AST will be knowing, AC will be knowing. Normally the total area of the column is given as A, area of concrete is AC, area of steel AST. You will be knowing AST and A, so AC can be found out using A minus AST. That I will take up when I take up the problem. So the thing is, you will be knowing AC and AST and P. So these three values you will be knowing, and length normally it will be same for both concrete and steel. In a column, length remains same for both concrete and steel. This is the length of the column. So that is A is equal to AC plus AST, or AC is A minus AST, and whatever load is applied on the column, that is shared by concrete and steel. So that is the main concept here. In compound bars, those two materials, they will share the load. So here PC and PST, they are the load shared by concrete and steel respectively. This total load is shared. For example, if total load is 1000 kilonewton, so concrete may take some 600 kilonewton and steel may take some 400 kilonewton. It need not be same. So it can be different also. So we know that stress developed in concrete is sigma C, and area of concrete is AC. So when you multiply stress by the area, you are going to get the force that is going to develop in that concrete. So since we know that stress is force divided by area, resistance divided by area, here if you want PC value, PC is nothing but stress multiplied by area. Similarly, PST will be whatever stress is going to develop in steel multiplied by area of steel. So that is the value of PST. So according to the equilibrium equation, your total load is equal to load taken by concrete plus load taken by steel. So if you use that equation is called as equilibrium equation. P is equal to PC plus PST. So PC is nothing but sigma C into AC, and PST is nothing but sigma ST into AST. So here P you will be knowing, AC you will be knowing, AST you will be knowing. The unknowns are sigma C and sigma ST. So there are two unknowns. So we need one more equation because there are two unknowns to solve. The another equation is called as compatibility equation. In structural analysis, compatibility equation is nothing but strain compatibility equation. That means what we assume is strain in concrete is the same as strain in steel. So, or in other words, whatever deformation takes place in concrete, delta LC, is the same in the case of steel also, delta L ST. So we know that for finding this delta L for the case of prismatic bars, the formula is PL by AC. AE. So that means here delta LC is nothing but PCLC by AC into EC we have to take, and delta LST is nothing but PST LST divided by AST into EST. So values of steel we have to take here, values of concrete we have to take here. Suppose if the LC and LST are they are same, if length of concrete and steel they are same as in this case. So here this is the length. So here this LC is equal to LST here. So from here to here steel is provided, from here to here concrete is there. So if LC is equal to LST in this equation, these two will be cancelled, and PC by AC is nothing but sigma C divided by EC will be there, and here PST by AST is nothing but sigma ST divided by EST will be there. So this equation is equation 2, which is called as compatibility equation. That means in this equation also you will be knowing EST value, Young's modulus of steel value you will be knowing, Young's modulus of concrete value they will give. So these two you will be knowing. So unknowns are these two. That means out of in these two equations, finally you have two unknowns, sigma C and sigma ST. They are the stresses that are going to develop in concrete and steel. They are unknowns. So P is known, AC is known, AST is known, EC is known, EST is known. Unknowns are sigma C and sigma ST. This is one example. Another example is there is a steel rod inside a copper tube. So this is the section. So here this is a tube. It has got some thickness, and inside this tube steel rod is there. So copper tube, steel rod. So this is subjected to some tension force or compression force, let us say. Here also there are two materials, one is copper, another is steel. So if you use the same concept here, whatever force P is acting on this compound bar, so it is shared by both copper and steel. So P is equal to PC plus PS. Once again PC is sigma C into AC, stress in copper into area of copper plus stress in steel into area of steel. Similarly, compatibility equation will be similar to this. Sigma C by EC is equal to sigma S by ES, where sigma C is stress in copper, EC is Young's modulus of copper. C stands for copper here. Sigma S is stress in steel, ES means Young's modulus of steel. So using these two equations also, we can find out the stresses in both copper and steel separately. Now I have taken an example or a problem here. You can see here I have taken this type. A circular rod of steel having diameter 20 mm. So this diameter is 20 mm. I have given the diagram here. Diameter of steel, this is the steel rod. So this steel rod has a diameter D 20 mm. Then it is rigidly fitted, firmly fitted into a copper tube. So this is the copper tube. Copper tube of inner diameter 20 mm. You can see that steel rod diameter is 20 mm. Copper tube diameter is, inner diameter is also 20 mm. There is no gap between that steel and copper. Then you have thickness of this as 5 mm. 5 mm is the thickness. So this is the longitudinal section. This is the cross section. This is subjected to a tensile force of 100 kilonewton. So tensile load. So I have taken this as tensile load of 100 kilonewton. This combination. So P value is 100 kilonewton. Young's modulus of steel 200 GPa. So GPa should be converted to MPa. 200 into 10 power 3 MPa. Young's modulus of copper is 120 GPa, which is 120 into 10 power 3 MPa. So you have to find the stresses in copper as well as stresses in steel, and also what is the force carried by copper and steel. So this force 100 kilonewton is distributed between copper and steel. One is PC, another is PS. So those values also we have to find out. Of course, once you find out the stress values, stress multiplied by the area gives the force. Now the procedure is very simple. So first I am applying the equilibrium equation. According to equilibrium equation, P is equal to PC plus PS here. So PC is sigma C into AC plus PS is sigma S into AS. P value is as given 100 kilonewton. Kilonewton should be converted to Newton. AC is nothing but, you see here, AC means area of the steel tube, steel rod, you can say. Steel is rod. So area of steel rod pi by 4, area of steel rod AS is pi by 4 into 20 square. You can see diameter is 20, so pi d square by 4 is the value of AS, and AC is area of this shaded copper tube. It's a tube, so you should know the difference between tube and rod. So tube, rod is circular, solid circular shape, whereas tube is hollow circular shape. So for this area, shaded area, the formula is pi by 4 into outer diameter. Outer diameter is 20 plus 5 plus 5. Outer diameter is 30 square minus inner diameter square, 20 square. So this is the value of AC in millimeter square. This is the value of AS in millimeter square. So you will be knowing these two values. Substitute those two values in this equation. So here I have kept it blank. You can fill it up. So whatever value you get here, that you have to write here. Whatever you are going to get here, that you have to write here. So this becomes equation 1. That is the equilibrium equation. Now the second equation is the compatibility equation. This is the compatibility equation. So compatibility equation, sigma C by EC is equal to sigma S by ES. So there also you will be knowing the values of EC and ES. So if you substitute and simplify, EC is 120 into 10 power 3, ES is 200 into 10 power 3. If you simplify this, it becomes 0.6. So 0.6 sigma S. So sigma C is 0.6 times sigma S. Now you have got two equations. This is equation 1, this is equation 2. So two equations, two unknowns. Sigma C and sigma S are the unknowns. You can easily solve. So very simple method. Substitute this. Substitute for sigma C as 0.6 into sigma S in equation 1 and then simplify. So then what happens? So the sigma C is converted to sigma S and only one unknown it will be. So if you simplify that, you are getting this value 181.6 MPa. Please check this. You can check this value. After getting the value of AC and AS, you can check this value. So 181.6 MPa means Newton per mm square. That is the stress that is going to develop in steel rod. Then substitute for sigma S and sigma S here. Get the value of sigma C. 0.6 times of this is 109.38 Newton per mm square. So that is the stress in copper. So one is stress in steel, another is stress in copper. Both are tensile stresses because it is subjected to tensile forces. Suppose if it is subjected to compressive force, these will be compressive stresses. Now these are the values of the stresses he has asked. Then he has asked what are the forces carried by the two materials. So PC is given by, we know the formula, stress into area, sigma C into AC. You know the value of sigma C here, 109.38 into AC value is this. So that you are going to get in newtons you are going to get, that you have to convert into kilonewton. So P value you are going to get in newtons. Then you can convert it into kilonewtons. Why it is newtons means here sigma S will be in Newton per mm square, area will be in mm square. So if you multiply them, you are going to get in Newton, then divide by 1000, you will get in kilonewton. Then similarly PS is sigma S into AS. So sigma S value is 181.6 Newton per mm square into AS is this value. So you are going to get the force carried by steel rod. This is force taken by copper tube, force carried by steel rod. The check is, you can check whether the answer is correct or not. Total force is 100. So if you add these two, PC and PS, you should get 100. So 42.95 plus 57.05, definitely it is 100. So our answer is correct. Even if it is small difference is there in decimals, you need not worry because of the rounding off. That small error you may get, that is not a problem. So this is how you have to do a problem of compound bar. So this is a compound bar because both copper and steel both are there here. So if we have only one material, then the procedure is different. If you have two materials, two unknowns will be there. You need two equations. One equation is equilibrium equation, which is nothing but the force equation. Another equation is called as a compatibility equation, which is nothing but the strain equation. Okay, thank you.